All right, guys, there we got the algebra of functions, sums, differences, products, and quotients of functions. Here's how we're going to do it. All we're going to do is going to be really, this is going to sound like a weird slide probably, but when you do, when you add, subtract, multiply, divide functions, that's actually what we're going to do. The way you would read this right here is you would say f plus g of x. And what that equals is just f of x plus g of x. Just literally add the two functions together. If you see this one, you read that f minus g of x, and you really just take f of x, subtract g of x from it. This right here would say f times g of x, which is really f of x times g of x. And the last one down here, f over g of x, you literally just divide f of x divided by g of x, but make sure g of x cannot equal 0 because you cannot have 0 in your denominator ever, ever, ever. Okay, here's a quick example. It says given that f of x equals x plus 1 and g of x is square root of x plus 3, find each of the following. Part A says f plus g of x. So I'm going to actually add f of x and g of x. So if I add f plus g, I would do the x plus 1 plus the square root. Now, this is a weird one because I can't really combine anything. So you actually just did the problem. You just added function f and function g, and that's fine. Now, part B says to do this, do f plus g of 6, which means you're going to take 6 and plug it in, f plus g, which is what we got in our part A. So I'm going to plug 6 in, and where I see it, x will be 6 plus 1 plus the square root of 6 plus 3. Now, 6 plus 1 is 7, and the square root is 9. So square root of 9 is 3. 7 plus 3 would be 10. You can look at that if you need to real quick. Part C, f plus g of negative 4. I'm actually going to take negative 4, plug it into f plus g. So I'm putting in negative 4 everywhere. I just put a 6 a second ago. So I get negative 4 plus 1 plus negative 4 plus 3. Now, you're not allowed to get a negative sign inside your radical, which means that is undefined. So this last one right here is undefined, does not exist because the negative inside my radical, and that's okay. Let me do that. Okay, now I want to show you this real quick. This is the same problem we just did, the graphical version. Like here was function g, there's function f, and the red one up here is function f plus g. And really all they did is they took the y coordinates on each one, added them up. Like that was a 3, that's a 7, so that's a 9. That's a 4, that's a 7, so that's 11. And they just added those up and connected them. And that's how you do it graphically. That's adding functions graphically. You would subtract them the same way, multiply them the same way, divide them the same way. Important here, domains of f plus g, f minus g, f times g, and f divided by g. If f and g are functions, then the domain of all these is the intersection of domain of f and the domain of g. What that means is whatever the domain of f and domain of g have in common, that's going to be the domain of the addition, subtraction, multiplication. Now the division, a little bit different, is the intersection, but you also have to think about what would make your denominator 0, and that also must be included in your domain. I hope that made a little bit of sense. I'm going to show you an example here, and hopefully it cleared up. Example 2 says, given that f of x equals x squared minus 4, and g of x is x plus 2, find each of the following. The first part says domain of the big 4. So the domain, first of all, there's no restriction there. There's no restriction there. Because the only time you have restrictions is if you have a radical that you can't be negative, or a fraction where you can't have a 0 in your denominator. So the domain for the first 3 are going to be negative infinity to positive infinity. That's true. That means all real numbers are good for this one, and this one. Now, the division one would look like this. If we were to set it up, it would say x squared minus 4 over x plus 2, which means that x cannot equal negative 2 because of making the denominator 0. So what I have to do there is I have to put everything besides negative 2. So you can write a couple ways. You can do this way. This is probably the quickest way. All x such that x cannot equal negative 2, and x is real. That's probably the best way to do that one. Okay, let's go on with the rest of these. This other one's going to be a lot quicker. Part B just says do f plus g of x. So if I'm going to do f plus g of x, I'm just going to add the two functions together. So I'd get x squared minus 4 plus x plus 2, which is going to give me x squared plus x minus 2. And that's all there is to it. Part C says f minus g f minus g, I'm going to do x squared minus 4 minus x plus 2. Don't forget that minus sign is going to change all my signs. X squared minus 4 minus x minus 2, which is going to be x squared minus x minus 6. Got to create a little room here. Part D says f divided by g of x. Actually, it says f times g. Sorry about that. It says f times g of x. Getting ahead of myself just a little bit. F times g of x. And that'll be x squared minus 4 times x plus 2. Looks like full method right there. So I'm going first, which is x cubed, outer 2x squared, inner minus 4x, last minus 8. And the beauty of that one is I'm done. There's nothing to add together. Two more. Part E, I know it's a little bit long. Part E, f over g. I'm going to do x squared minus 4 over x plus 2. And I'll be honest, most times you're going to be done right there. But what I noticed on my numerators have a difference of squares, so I can make that x plus 2, x minus 2. And one reason I went ahead and did that step was because I noticed that these two would cancel. So it just leaves me x minus 2. And the last one says g times g of x. So I'm actually going to work out part F here, which is g. So I'm going to do x plus 2 times x plus 2, which is really x plus 2 squared. Remember how we do that? You square the first one, you multiply together, double, you square the second, and there's that one. Hopefully it wasn't too bad. That's a lot of stuff on one slide, though. All right, this is a special function right here. It's called the different, well, it's called a quotient, not really a function. So it's a difference quotient. Difference quotients, we do f of x plus h minus f of x all over h. And to be honest, this has mainly calculus applications, but it's something you do need to know how to calculate because most of you are going to be there anyway. So let's figure it out. It's just a calculation is all it is. Let me show you an example, but remember it's called the difference quotient. F of x plus h minus f of x over h. It actually finds average rate of change in calculus and also the slope of a secant line. Okay, they're going to give me a function right here, and I'm going to say find and simplify the difference quotients. What I'm going to do is exactly what it says. The first thing it says is f of x plus h. It may be useful to do it this way. Take a part at a time. So f of x plus h should be plugging in the x plus h. So if I do that, I would get 2x plus 2h minus 3. Then it just says f of x. F of x is just a function, which is 2x minus 3. So when I actually come down here to work this out, I'm going to change colors. When I come down here to work this out, I'm going to get the f of x plus h, which is this, minus this f of x, and put that all over h. And what's going to happen, usually it simplifies pretty neatly a lot of times. So let's see what happens here. I have 2x plus 2h minus 3. The minus sign changes the signs in here all over the h, and look what happens. My 2x's are gone, my 3's are gone. All that leaves is a 2h over h, which is just 2. And there's your difference quotient. That's how you can work it out. Figure out your two parts first, probably a good idea. Plug them in your difference quotient and just simplify the best you can. I'm going to show you one more of those. One more of these and we'll be done. I want to show you one with a fraction so it won't blow your mind tomorrow when you see this. First of all, I'm going to find f of x plus h, which is just plugging x plus h in, which is that. F of x is just 1 over x. Now I'm going to do the actual difference quotient. I'm going to plug them in here. So I'm going to have 1 over x plus h minus 1 over x all over h. Now, what I would do, my recommendation here is always to multiply everything by the LCD. And the LCD is every d. So I'm going to multiply the whole top by x and x plus h, and the whole bottom times x and x plus h. And the reason I'm allowed to do that is because what I'm multiplying by, this fraction right here, actually equals 1. So I'm not changing the value any. It's just going to simplify it for me. So what I'm going to have, what's going to happen is when I multiply this term times this term, the x plus h's would cancel. And so what that would leave me with is a 1 times the x, or just x. My second part, if I do that one, my x's would cancel, so it would be 1 times x plus h, which would just be, I'm trying to fix it, there we go, x minus x plus h. And on my denominator, I'm going to have all this stuff now. because I have to multiply the denominator also. So on the numerator, I have x minus h. My denominator, I have all this stuff. Okay, so my numerator, what I'm noticing is those cancel. So all I have left in my numerator is a negative h. On the bottom, I still have all this stuff. And so when I simplify that, I can do one more little thing. I'm going to move it just a little bit. My h's would cancel, which leave me a negative 1 on the top. And on my denominator, I have an x and an x plus h. That's as far as I can go with that. A lot of times, that's what your answer is going to look like on those. You just simplify them as much as you possibly can, and that's all you can do. So call it the difference quotient, calculus applications. We'll work on them tomorrow. Hopefully it wasn't too bad, except for that last part. But even that one shouldn't have been too bad. Take some good notes. See you tomorrow.